6.7 Financial Models. Simple interest formula. If a principal of P dollars is borrowed for a period of T years at a per annum interest rate R expressed as a decimal, the interest I charged is I equals PRT. Interest charged according to the formula above is called simple interest. In problems involving interest, the term payment period is defined as follows. Annually is once per year, semi-annually is twice per year, quarterly 4 times per year, monthly 12 times per year, daily 360 times per year. Interest is money paid for the use of money. The total amount borrowed, whether by an individual from a bank in the form of a loan or by the bank from an individual in the form of a savings account, is called the principal. The rate of interest expressed as a percent is the amount charged for the use of the principal for a given period of time, usually on a yearly basis. When the interest due at the end of payment period is added to the principal so that the interest computed at the end of the next payment period is based on this new principal amount, old principal plus interest. The interest is said to have been compounded. Compounded interest is interest paid on the principal and on previously earned interest. Compound interest. A credit union pays interest of 2% per annual compounded quarterly on a certain savings plan. If 1,000 is deposited in the plan and the investment is left to accumulate, how much money will be in the account after 1 year? All right, so we're saying we have an interest, it pays this much, this amount of time. This is a simple interest formula because we want to know how much interest are we earning. So P is our deposit amount, our initial investment, or our loan amount. So it's going to be how much did you start off taking or plugging back into your account. We need to find our R, which is our rate. Our rate is our interest rate. How much are they giving us every time they compound? And it's 2%. So it's 2%, that means it's 0.02. That's what it meant up here, how it says that R is expressed as a decimal, so we just change it to a decimal. And then our compounding, how much we're compounding by. So we're compounding quarterly every year, so that's 1/4 every year. Now, there is a difference between time and N when we're talking about interest and principal and money and stuff like that. Since this is a time, they're compounding quarterly. Quarterly is a 4 every year. Let's plug everything in to figure out how much interest we did earn. So the interest we're earning is our principal, which is 1,000. That's how much we deposit, times our rate, which is 0.02, times our compounding, which is a quarter, and we get 5. So that means you earned $5 in 1 year if you deposit $1,000. Compounded interest. The amount A after T years due to a principal P invested at an annual interest rate R expressed as a decimal compounded N times per year. So these are comparing investments using different compound rates. So this is just something to look at and to review. So let's say you're investing $1,000 at an annual rate of 10% compounded annually, semi-annually, quarterly, monthly, and daily. So you're gonna see what's the difference if I put $1,000 and it's a 10% interest rate of how much am I gonna get back if we compound annually, semi-annually, quarterly, monthly, and daily. So annually, we would only earn $100 because we deposited 1,000 and now we have 1,100. So annually, we would have $1,000. So our P, that's how much we're depositing into the account. So our P is 1,000. Our rate is 10%, so that means our R is 0.10. And our annually, semi-annually, that's where our N comes from. So our N, that's when we have how much are you doing this per year. So semi-annually is 2, quarterly is 4, and we have each representation of that. Continuous compounding. The amount A after T years due to a principal P invested at an annual interest rate R compounded continuously is A equals P e to the power of RT. This is how we revert back to everything we've been doing in chapter 6. So the amount A that results from an investing a principal P of $1,000 at an annual rate R of 10% compounded continuously for time T of 1 year is blank. So we know that this is a continuous compound because it says compounded continuously. So that's how we knew to use this formula, because it said compound continuously. So because we know to use this formula, we only need a couple things. We need our P, which is our principal, and that's $1,000, times E. Remember, E is not a variable, it just represents a number, so we just leave E as E. We have our R, that's your rate. So your R is your rate, and this is a rate of 10%. So if our rate is 10%, we know that's 0.10. You can say 0.1 as well, they mean the same thing. And then our time is 1 year. That's why you don't see it here, because 1, it doesn't change anything. It's just 1, so they didn't list it. So we plug that into your calculator, and you would get $1,105.17. Effective rate of interest. The effective rate of interest, ROV, of an investment earning an annual interest rate R is given by, so we have two. We have compounding effective rate of interest and continuous compounding. So if you're compounding a certain times per year, we get our effective rate of interest is 1 plus R over N to the power of N minus 1. And if we're compounding continuously, it's E to the power of R minus 1. Computing the effective rate of interest, which is the better deal. So you are or have or will soon sign up for a bank account or a credit card or a credit union, and you'll be offered all these details about a savings account and stuff like that. So you're going to figure out which one is going to be the best for me, which one is going to give me the most money with the money I put in. So suppose you want to buy a 5-year certificate of deposit, that's called a CD. You visit 3 banks to determine their CD rates. American Express offers 2.15% annual interest compounded monthly. First Internet Bank offers 2.20% compounded quarterly. Discover offers 2.12% compounded daily. Determine which bank is offering the best deal. The bank that offers the best deal is the one with the highest effective interest rate. Since it says compounding monthly, quarterly, and daily, we know we're going to be using our compounding n times per year formula. So we want to know what the effective rate is compounded a certain time amount every so often. We're going to be using R sub e equals 1 plus R over n to the power of n minus 1. So we have 3 banks that we're comparing. We're comparing American Express, and they offer 2.15% compounded monthly. So American Express, the compound rate is 2.15%, which we know is going to be 0.0215, and it's compounded monthly. So monthly is 12. Your N is how often do you compound. Let's bring them out for each single one. So that's American Express. Let's go ahead and do First Internet Bank. So First Internet Bank, their rate is 2.20%, which we know is going to be 0.022%. And it's compounded quarterly, so quarterly is 4. And now our last one, Discover. Discover has a rate of 2.12%, so we know that's going to be 0.0212. and then it's compounded daily, so there's 365 days. We don't count leap years because guess what? They don't count leap years. Now that we have our rate and our compounded, our n, we can just plug it into our formula. So we have effective rate of return. We have 1 plus blank over blank to the power of blank, all minus 1. And our first blank is r. Our r is 0.0215. Our second blank is n, which is 12. Our exponent is n, which is 12. I'm going to show you how to put this into your calculator because I haven't done that yet for this chapter. So I want to show us how do we plug this into our calculator. So I'm going to show you two ways because it just depends on if you have a new calculator or old calculator for TI-84. Again, I only know how to use the TI-84, so if you have a different calculator, you're going to have to look up or go to the MATLAB Center to figure out your calculator. So let's plug this in. We have parentheses 1 plus. Now if you have a new calculator, you're going to hit alpha y equals enter. We have 0.0215 over n, which is 12. Close out those parentheses. It has to the power of 12. And then all minus 1. And we get 0.02171335. So if our rate is 0.02171, that means our rate as a percentage is 2.171%. Now we have to do them for each and every single one of them. Now let's say you have an older calculator. How would we approach this with an older calculator? So with an older calculator, we would have parentheses 1 plus parentheses again 0.0215 over 12. So that's closing out the fraction, that's closing out the parentheses, all to the power of 12 minus 1. Or if you have a different calculator, you can do it piece by piece. So you could do our decimal, so 0.0215 divided by 12. We get a decimal. We know we need to add 1. So we add 1, and that's all to the power of 12. And then that's all minus 1. So you can also do it piece by piece and you still get the same answer. You can take it all as 1, you can do it as a fraction bar with a division symbol, or you can do it piece by piece. Alright, first internet bank. Pretty much same setup, but just different numbers. So we have 1 plus blank over blank, all to the power of blank minus 1. And our first blank, that represents r, so our r is 0.022. And our second blank, that's n, that represents 4. And our exponent, we have 4. When you plug that into your calculator, you should get about 0.02218, which we know is going to be 2.218%. Last but not least, we have Discover. So for Discover, it's pretty much the same deal, just different numbers. We have 1 plus blank over blank to the power of blank, all minus 1. And our first blank, our rate is 0.0212. Our compounding is 365. We probably automatically think that Discover is the best because you compound every day. Well, that's only true with simple. When we compound a little more complex things like this, especially effective rate of return, sometimes compounding every day is not going to give us the best rate. When we plug this into our calculator, we get 0.02143, which is 2.143%. So the biggest number, that's going to be the best deal. So our biggest number is 2.218%. That means that's going to be the best effective rate of return. Now, what's the difference between effective rate and normal interest rate? Because you hear these words like this is your interest rate, but this is what matters. Effective rate of interest is what matters. So let me tell you the difference. Normal interest, that's actually called nominal interest rate. So nominal interest rate is the interest rate that is advertised or stated on a loan or investment without taking into account the effects of compounding. That's why it's called simple interest. It's where this is your normal interest rate. Here you go. Effective rate of interest is the actual interest rate that is earned or paid on the investment or loan over time. It takes into account your compounding. So simple interest is just advertised regular interest. Effective rate of interest is the actual interest you're earning over a period of time. So you can say, I'm going to do this for 10 years. You're going to earn 2.218% with everything you put in. Present value formulas. The present value P of $8 to be received after T years, assuming a per annum interest rate R compounded n times per year, is P equals A times 1 plus R over n to the power of negative nt. If the interest is compounded continuously, then P equals A times e to the power of negative RT. A zero coupon non-interest bearing bond can be redeemed in 10 years for $1,000. How much would you be willing to pay for it now if you wanted a return of 7% compounded continuously and 8% compounded monthly? So now we're asking, if I gave this much money and it says in 10 years you'll earn this $1,000, how much do you have to pay right now? So if I'm saying in 10 years I'm going to get $1,000, how much do I have to put down right now to earn $1,000 in 10 years? Alrighty, part A, we're compounding continuously. 7% compounded continuous. Since we're compounding continuously, we need to use P equals A e to the power of negative RT. So A is your how much do you want to get out of this. It's not your how much are you putting in now. That's what P stands for. P represents how much do you put in now. That's your initial money. Whether it be a loan or a savings account, that's just how much is right now. A is how much are you getting out of it. So A is how much money are you ending up with? And that's, in this case, it's $1,000. We want to know, when do we get $1,000? Like, how much do we have to put down now in 10 years to get $1,000? Our R never changes. That's going to be your rate. So our R still stands for our rate. In this case, it's 7%. So 7%, we know that's 0.07. And then T, that is always time. I said that in the beginning of the semester. T is always time. Lowercase t, uppercase uppercase T is going to be temperature. So our time is we're doing this for 10 years. All right, let's plug it into our handy dandy formula. So we have how much do we want to put down now? That's P equals A, which is how much we want to get out of it. That's $1,000 times E. Remember, E is just a number. It's 2.71. And we have minus R. Our R is 0.07. And times time, which is 10. You know how to plug stuff like this into your calculator. And you will get 496.59. So that means in 10 years, with an account with a non-interest bearing bond that's 7% compounded continuously, in 10 years, if you put $496.59 now, in 10 years you'll have $1,000. Okay, what about if we compound monthly at 8%? How much do we have to fork up now? So we're compounding monthly. Since we're compounding monthly, that's a certain amount of time. That means we need to use this formula. So our formula, we have P equals A times 1 plus R over N to the power of negative NT. All right, P, that's not changing. That's how much we want to know. How much now do we have to fork up? A, that's not changing. We still want $1,000 at the end of this. Our rate, that's what's changing because now we're 8% rate. 8% is going to be 0.08. And this time we have an N because we're compounding a certain amount of times. We're compounding monthly, so our N is 12. Time, that hasn't changed. We're still doing this for 10 years. Let's plug it in. We want to know how much do we have to put down now? How much do we have to fork up right now? And if we fork up that money right now, I want to know how much do I have to put up now to do $1,000? So we have 1,000 times 1 plus our rate, which is 0.08, over n, which is 12, all times the power of negative nt. Our n again was 12. Our t again is time, which is 10. Plug that into your handy dandy calculator, and we get 450.52. So if I asked what's the better deal, A is the better deal because you have to put $4 less to earn $1,000 in 10 years. So what part A is actually saying, for a return of 7%, you're going to pay $496.59 for the bond right now. For a return of 8%, that's part B, for a return of 8%, you pay $450.52 for the bond. Determining the rate of interest required to double an investment. What rate of interest compounded annually is needed in order to double an investment in 5 years? So we want to know, what interest rate do we need in order to double my investment? Because maybe that's what we're looking for. I want to know, if I have it for 5 years, what interest rate should I shop for to double my interest? So we are compounding a certain amount of times per year. Since we're compounding, now this is not saying how much do I need to fork up now. This is how much can I get later. If you're asking how much can I get later, you're finding A. And since we're compounding, it's A equals P times 1 plus R over N to the power of NT. You use this formula if you want to know how much do I need to put money in now to get this return. You use this formula without the minus if you're saying, I have this much money to put down, give me the return. So we're looking for the rate. What rate of interest? So we're looking for R. We don't know it. We're compounding annually. So annually means every once a year. Monthly is 12. Annually is 1. And our time, we want to do this for 5 years. And we're looking to double our investment. Investment stands for P. Because we said P is your initial. Your initial, there's many synonyms for that. A synonym for that is investment. And if we're looking to double our investment stands for P and double stands for 2. So we want to double the investment. If we want to double the investment, we want to do 2 times RP. We don't know RP. We just want to know how can we double the P that we have? So we don't know how much money we're getting. We don't know how much money that we want to get out of this or put in. We just want to double the investment. So we know at the end of it, our A, we want it to be double what we put down. So we're going to have 2P equals however much we're putting down times 1 plus R over N. R, we don't know. That's what we're trying to find. Our N is 1. All to the power of nt, so 1 times t, and our t is 5. So what this is saying is I want to double my investment, whatever that investment is. To double it, I need some type of interest rate. I'm doing it once a year for 5 years. So we can start simplifying. Because there's no plus and minus right here, because there's no plus and minus right there, we can actually divide by p. And when we do, we're left with 2 equals 1 plus r over 1 is just r. 1 times 5, that's just 5. Alright, we still need to solve for r, and r is attached to an exponent of 5. That means we need to take the 5th root of each side. Because what that does is it gets rid of our exponent. So we have the 5th root of 2, which doesn't exist. It's just a random number. I mean, it exists, but it's not an actual number right now. So we have the 5th root of 2 equals 1 plus r. We're going to subtract 1 to get r by itself. We have the 5th root of 2, all minus 1 equals r. We need to take the 5th root of 2. Look up how to take different types of root with your calculator, but with a TI-84 or an 83 or an 82, I can show you. Alright, we need to find the 5th root of 2 and then minus it by 1. So you hit math. You can go down to here to number 4. I know that says cubed, but that's okay because we can go back and highlight it. Instead of 3, that needs to be a 5. And we're taking the 5th root of 2, which we get 1.148698355. And then we need to subtract by 1. So minus 1. And we got 0.148698355. So we get about 0.14868 is our rate, which that's in decimal form. So as a percentage, we have 14.87%. There's a 9 next to it, that's why we round up. So what we just found was the annual rate of interest to double the principal in 5 years is 14.87%. So if you wanted to put $5 in, and in 5 years you wanted $10, you would need an interest rate of about 15% in order for that to happen. If you're wondering, where do logarithms come in? Because we talked about e and we talked about exponents, that's all chapter 6. But the other part of chapter 6, the logarithms, that's where example 7 is. How long will it take for an investment to double in value if it earns 5% compounded continuously? How long will it take to triple at this rate? So we're compounding continuously. Since we're compounding continuously, we know we're going to use A equals P E power RT because it's continuous. So we're looking for how long. How long is always t. If we're saying how long is something, we're always looking for time. Like if I'm asking how long is the movie, how long are we going to be there, how long till we leave, we're looking for time. So we don't know time. We're trying to find it. And then we're looking for the investment to double. So however much we're putting down, we want it to double at the end of the day. So at the end of the day, we want this to double. And it's 5% compounded continuously. So that's our rate. Our rate is 5%, which we know is 0.05. Let's plug it in. We have how much we want. We don't know how much we want. We just want to double it. So we have 2 times however much we put in equals however much we put in. We don't know how much we're putting down. So P times e to the power of r, our rate is 0.05, and then t. That's what we're trying to find. We want to know how long will this take. We're solving for an exponent. When we're solving an exponent with e and t, we have to turn this into a logarithm. And because it's e, we switch it to ln. Remember, ln and e, those are the ones that go together because they're special. So we need to switch this. Before we switch it, though, we can start simplifying. Because there's nothing in front, or there's no plus or minus right here, since there's no plus and minus between p and e, we can divide by p. So when we divide by p, we're left with p equals e to the power of 0.05t. Now we can switch it to a logarithm. So our base is e, therefore it's ln. Our equation equals 2, so that's our argument. And what's left over is 0.05t. In order to solve for t, we'll divide by 0.05. And when you do, you get 13.86 equals t. So what does this mean? It's going to take 14 years to double your investment. So if you throw in money, so let's say again $5, let's make it easy money. So let's say that you want to double that at a 5% compounded continuously. It would take you 14 years. Now we want to know, how long was it going to take to triple? So we set this up very similarly. Instead of doubling, we're just tripling whatever we throw down now. So instead of 2a, since we want to triple, our A is going to be 3 times our principal, our investment, because we want to know how long is it going to take to triple what we throw down. What you throw down represents P. A is the answer to that of how much money do you get. So our A is going to stand for 3P. Our rate doesn't change because we want to know how long will it take to triple at this rate. So our rate is going to be exactly the same. So, but the only thing that's changing, instead of doubling it, we want to triple it. So we'll have 3p equals p times e to the power of 0.05t. Just like before, because there's nothing next to p and d, there's no plus or minus, we are allowed to divide by p. And when we divide by p, we're left with 3 equals e to the power of 0.05t. And guess what? Because you're solving for an exponent, you simplify this and solve it the same exact way as part A. So we're going to switch this to ln. Why? Because it has e and we're solving for an exponent. Anytime you have e and you're solving for an exponent, you're switching to ln. So we have ln3 equals 0.05t. We divide by 0.05. And when we do, we get 21.97 is t. That means 22 years to triple your investment. So if you are compounding 5% continuously and you want to triple your investment, it'll take 22 years.